piratey.
Yeah, I don't.
Seaborn.
You know,
Arg.
Seaborn. All right. Yes. You landlubbers. I don't know. All right. Thanks. I'm making myself laugh. All right. All right. So Seaborn is a library that's, we don't call them library. We call them modules. Modules built on Matplotlib, and so you have to load up these other things. It runs on pandas and NumPy and so you got to load all of those things. And this is kind of the default, the letter schemes we use to name these things. One important thing to note, because later on we can kind of fit some linear models and stuff to our data, but Seaborn is for visual exploration. It's not for building stats models. Okay, so you want to do like linear regression and make predictions and stuff like that. This is not the package for it. You can fit a linear model, you can fit a regression line, but Seaborn will not tell you its coefficients. And it's like if you go on like, how do I get the coefficients out of Seaborn? Basically, the people who write the package will say like, this is not the purpose of Seaborn, and we are not going to implement this feature, even though it's probably easy to implement. They don't want it for that. Okay. You're gonna see some warnings whenever I do this dist plot thing, and that's because Matplotlib updated their histogram function, and it no longer uses this normed thing, but they call it density. So if you, instead of turning it into, so that the, relative proportions add up to 1 or whatever, they changed it to density instead of normed. And so every time, and Seaborn, they're going to patch it, but they haven't released the updated patch. And so every time I call this function dist plot or anytime Seaborn does something with a histogram, we're going to see this warning. Okay, you don't have to worry about it. It'll go away at some point in the future when they update Seaborn. But this is what we have. Okay, so first of all, we'll just start off with univariate exploration. Now, with Matplotlib, we've got the pyplot or plt.hist to produce histograms, and but if you want to do kernel density estimation, you have to load up this additional kind of module that will do Gaussian densities, and Seaborn does this easy for us. Okay, so all you have to do is, so here I'm just generating some random univariate normal data, and I just call Seaborn sns.distplot for distribution plot, and the default settings are make a histogram and add a kernel density. All right, so that's nice. Okay. So we got it, it needs to be patched. All right. If you just want the histogram, you can say KDE equals false. You can also pass other arguments like bins equals 20, and you can add a rug plot. So you can say rug equals true, and then you'll see all the values that were actually drawn, and there's your histogram. Okay. And then likewise, if you want it just the other way, if you just want the kernel density, you can say hist equals false, and then if you want the rug, you can add rug equals true or whatever. Here, let me hit Shift Enter as we go through these things. KDE and
what was KDE stand for?
Kernel density estimation. Okay. And did I do a brief talk about how the kernel density estimators work? Basically, you're just like drawing like a mini Gaussian curve centered at each data point, and then when you do all of these and you stack them on top of each other, you get the KDE. If you want to change certain properties of the kernel density estimate, you have to call KDE plot. You can't do it within the distribution plot. Distribution plot uses just kind of the default bandwidth, but if you want to like change things like the bandwidth to something smaller, you have to call KDE plot and mess with it there. So if I did KDE plot 12, then you get something that looks very much like a regular normal curve. 0.2 makes it a little bit more jagged, and O2 would this would be a terrible plot to use. But anyway, so there's messing with kernel density estimates. Okay, so that's all just kind of like univariate. I don't know, distribution exploration for one numeric variable at a time. Okay, here we can look at bivariate plots, and so here I'm going to create multivariate normal data, and this will produce an XY NumPy array, a NumPy array of 200 rows, 2 columns, and then we just throw that into Panda's data frame, and we say we're going to call the columns X and call the columns Y, and if we print that out, we see kind of the head of our multivariate data. So it's centered at 0 with covariance 1.5.51. Okay. And so Seaborn makes the next part real easy, and we have Sns Joint Plot. I don't know if you guys remember kind of the pain in the butt grid thing that we had to do in Wednesday's lecture. If we wanted, where did it go? This thing, okay? If we wanted something that looks like this, we had to write all of this code, right? We had to do grid spec and then specify which parts of the grid were going to be the scatter plot and which parts were going to be the histogram, and we had to specify all of that, okay? This was just an illustrative example. We would never do this because we have Seaborn, and all you have to do is joint plot. You need to tell what's your X, what's your Y, and your data, and then it does pretty much the exact plot that we wanted. The scatter plot and the respective histograms on each side. Okay, so and the Pearson correlation coefficient gets printed there. And is this significant correlation? Yes, it is, because the p-value associated with this from happening by random chances on the order of 10 to the negative 17. Okay, if they were truly uncorrelated. Okay, so that's joint plot, which is like, we love this thing, right? Okay, and you can also change it. If you don't like dots and bars, you can say kind equals KDE, and then instead of a histogram, it's going to produce kernel density estimates, and instead of the scatter plot, you get a 2D kernel density estimate thing. Okay, same thing. Joint plot. All of these things, just if you're not sure how to do any of this stuff, Google is your friend, and the Seaborn documentation, you just say like Seaborn whatever, okay? And I'm just really copying a bunch of stuff out of the tutorial and the example gallery, and you can always look at what other people did online. Let me close this. So that is your joint plot kernel density estimator there. Okay. Let me zoom out just a minute. Okay, and then if you have a bunch of numeric data, this is kind of like a pairs plot in R, pairwise plots. So here I'm loading up, our old friend Iris, and we'll do pair plot Iris, and so we've got the 4 variables: sepal length, sepal width, sepal petal length, and petal width, and we can see kind of the correlations between sepal length and sepal width and all of that, and there's that thing. And rather than leaving blanks down the diagonal in R, the pairs plot, they just have the variable name down the diagonal. Here we have histograms, okay, in this direction. So we can see, we got a bunch of points here for petal length, and so we have a, bimodal histogram right here and things like that, okay. Similarly for petal width, I guess it's multimodal. For whatever reason, we don't have very many dots in this zone, but there you have it, okay. So there's pairwise plots. The command for that is seaborn.pairplot, and then you throw in your data set, okay. And if you have categorical and numeric variables mixed in there, Seaborn's smart enough to say to only do it for the numeric variables. Okay, so basically, when you load up the data and you in pandas and you ask, kind of info, and it summarizes, or it tells you what kind it is. It'll only do it for the numeric ones. Okay. Here we'll take a look at another data set called tips. Okay, this is a data set that comes with Seaborn, and so we use this, and apparently we went to some restaurant and we just recorded, how much was the bill, how much tip they left, and was the person male or female, were they a smoker, what day was it, what dinner or whatever, how many people. So this must be like from a long time ago, because this is 2 people. Size 2 is the party, and their total bill was $17, and they left $1 tip. So 2 people eating at a table service restaurant for $18. It's hard to come by these days, right? And so on and so forth. Okay. Univariate plots separated by category. So anyway, we look at this, and then we can also see we have numeric variables, total bill, and tip, and then the categorical variables are sex, smoker, day, and time, and then the size is a numeric variable as well. Okay, so you can we could just look at one variable, but if here I'm going to assign a categorical variable day to the x-axis, and the total bill, the numeric variable, to the y-axis. Okay, and I call strip plot. These are like, I don't know, non-standard names. These are not like, I'm not used to hearing these things, but because this is what Seaborn calls them, people now understand what they mean by a strip plot. But outside of Seaborn, I don't know if we ever call these things strip plots. It's basically a dot plot, but it's in a single strip, and so when there's dots stacked on top of each other, you can't really see them, right? So that's a little bit of a problem. So one thing we can do to adjust that is throw in the parameter jitter. Jitter equals true, and that just shakes them up and allows you to see where there was a bunch of overlap. Okay, so it's same thing, but now we're just like kind of jittering them. that's, and R has a similar function as well. So you can do this. And then there's something called a swarm plot. So we're looking, these are all like variants of the same information. So X is day, Y is total bill. Let me load up. So jitter is true. Okay, swarm plots, they're kind of like dot plots, except generally dot plots look a little bit more like a histogram in here. They're like, I don't know, symmetric ish. And so there you go. Okay, so this carries just the same information, but you get these funny shapes here. Okay, on top of this, if you have another categorical variable, you can map the categorical variable to the color of the dots. So here the default setting is like for each day it chooses a different color. I mean, we could also, what is the option? Do I want hue equals, will that work? No. Maybe color equals, okay. I don't know what the, okay, color equals red, and this will, make sure all of the things. The default is this. But here, if I specify hue is equal to a categorical variable, then it will color each of these dots according to the sex of, I think this is the server. Yeah.
Oh, is X time series or just like categorical?
X is just categorical. So we had 244 data points, and some of the data came in on Thursday, and some came in on Friday and Saturday and Sunday. I don't know what kind of restaurant this is, because I don't know any restaurant that's more crowded on Thursday than it is on Friday. But apparently this is what has happened, huh? Yeah, maybe they have Thursday happy hour. This is, I mean, it's possible. I don't know where the data came from. The total bill size seems really tiny to me. But like Iris, we don't know who well, Iris, I think Fisher went and measured all of these flowers. Huh? The Iris data? Yeah, they took flowers. Somebody's having a party out there. They took a bunch of flowers, irises, and they actually measured with a little ruler how wide the petals were and how long the petals were. We're not making this up. Data collection is hard. It used to be really hard, and that's for petals. That's like easy. But then it's like, oh, we want to measure like how much wheat grows. You had to wait like 9 months for the wheat to grow. I don't know anything about wheat. I don't know how fast wheat grows, but you had to wait like an entire seasonal harvest and see like this. Did you guys learn about the Latin square in
in 101B?
Did they show the Latin square wheat picture?
I don't remember.
It was in the textbook. It was in the textbook.
I remember the one with
square
cows.
wheat. Oh, come on.
Interesting selection.
No.
Easily dry.
Latin square design. I'm sorry, this is completely unrelated, but it was
I'm curious
it was
now.
very
I'm
exciting. When I saw it, I thought, wow, this is amazing, but
You can just Latin square design wheat.
Latin square design wheat. Come on. Farm. All right. Okay. My heart's broken. Okay. Yeah, some other day.
The suspense is
So anyway,
real.
okay. This is what we have. And then, again, so similarly, we can map it the other way, and we can say we want to map sex to the X, and we'll color the dots based on the day. So these two things have the exact same information. This one's a lot harder on the eyes, in my opinion, because I don't know. There's too much color going on, right?
Mm-hmm.
So, whatever it is going on here, okay? But same info, just presented in another way. We got our traditional box plots. So all of these things, X along one axis, and then so here, wait, let me just do that, and then let me copy this and paste it here. And if I swap this around and I said Y is day and X is total bill, then you get the box plot horizontally, okay? So it's not, you don't do like in R, you set it up and then you say horizontal equals true or something like that. Here you just say Y is the numeric variable and the X is going to be the day, okay? And if you specify the color, the hue, to be another categorical variable, then you'll get these side-by-side box plots for each each day. So this information is, apparently the same as this, although this is a swarm plot and it's all kind of like messy. And over here you have the box plot, okay? All right, and then lastly, we have these things called violin plots. I'm not a huge fan of violin plots. I don't know who makes, well, anyway. Look up violin plot XKCD. It's kind of funny, but we'll just leave it at that. And so here I have X day, Y is total bill, and hue is sex, and so it says this is the distribution for males and females and things like that. Okay, and so these are this is what we have. Okay. All right. Is that right? So we got probably stick to the box plots and swarm plots, even though they're a little bit messy here. Okay. All right, is that all right? You looked it up. Okay. Yeah. All right. It's like Georgia O'Keeffe, right? So, okay. Facet grids to make several plots. So this, I think, is a pretty cool thing. Is you can use seaborn.facetGrid, okay? And with seaborn.facetGrid, you specify the data set. Then you specify how you want to split your graph based on a variable. So you provide like a column, and you give it one of the categorical variables. So we're going to create in our graph, we will have a column of plots from one sex and column of plots for the other sex. That's what we have here. Okay, and then margin titles equals true throws in the titles. Okay, and then the facet grid will subset the data based on the categorical variable you provide. And then what you do is you create this facet grid, and we're going to call it G for grid. And then you do g.map. And what map does is it takes a graphic function. So in this case, we're calling the function sns.distplot, which back here, looks like this. Makes a histogram and kernel density estimate, right? So we're passing the grid to the grid. We're passing a graphic function, sns.distplot, okay? And then sns.distplot itself takes parameters such as what variable are you going to make a distribution plot for? And in that case, we're going to make a distribution plot for total bill. And maybe we want to say we want 10 bins. So we say bins equals 10. So you don't put those in the parentheses for distplot. You say I want the function distplot, and these are kind of the parameters that I'm passing to distplot. Okay, and when you do that, it creates a distribution plot after it has subset the data to sex equals male, and then a distribution plot after it's subset the data to sex equals female. All right. Likewise, you can create a facet grid where you give the row a category. So here we're doing tips, row equals day, margin underscore titles equals true, and then we're going to map a function. In this case, we're going to do plot pyplot from matplotlib histogram. Okay, and we can do total bill. We can do whatever we want. We can do it for tips, and it will. Oh no, it's called tip, and we can create a plot there. If we wanted to do sns dot box plot. Wait, is it not called box plot? What did I do wrong? Oh, x equals dense tip, and then I have to get rid of these other things, right? What's it saying? We cannot interpret input tip. All right, I don't know what's going on.
Oh.
Okay, I broke it.
Put days in.
Okay, here we go. Well, I've already faceted it on day. Okay, so I've already faceted the plot based on day. So we got facet grid in here like this. Okay, so I mean this is probably preferable. Okay, for something like that, especially because box plots are made to be plotted side by side, but whereas a histogram probably kind of makes sense like this. All right, so here we've got we split the data up by day, and then we do this, and then lastly you can even have a 2D thing where you split it up by time and sex. So you split it up by the categorical variable, time being whether was it lunch or was it dinner, and sex being was the server male or was the server female. I think that's what it is. And so now we're doing, do a histogram for total bill, and it creates kind of four histograms based on how it has subset the data. All right, yes, question.
So is Seaborn like a complete replacement for Matplotlib? Kind of like ggplot for base R? There's some things that easier in base R, but
I wouldn't say it's a replacement. It's kind of like it's a thing that's built on top of Matplotlib and Pandas to make certain common statistical graphs easy. Okay, so it's more like shortcuts for common statistical graphs that we make versus kind of like the joint plot with the 2D scatter plot in the middle and the histograms. It's like a pain to make that in Matplotlib, but with Seaborn it makes it easy. And so a lot of these things are made easy. You don't have to, like with Matplotlib, you'd have to do subplot 221, subplot 222, and specify each of these things. And you just set up a facet grid, and then you do these things, and it just makes life a little bit easier and faster. Okay, but I wouldn't say it's a total replacement or things like that. And again, it's for kind of exploratory visual analysis and not for statistical modeling. You can do a little bit of statistical modeling here, but it's not for that. There's no option to pull out the coefficients or things like that. Okay. If you got straight categorical data, again, I don't know why all of these things are called the things that they are, but we call this a count plot rather than just a simple bar chart. But so here we're going to just count how many male versus female. So this is count plot. If you want to have a side-by-side bar chart, you do count plot, and then you specify two categorical variables, and you get that thing. Okay. Okay, and then all right, fitting some basic stats models. So if you wanted to create linear regression and fit scatter plot and fit just a linear model, you can do Seaborn LM for linear model plot. X equals total bill, Y equals tip, data equals tips. There's no way to pull out the coefficients of this thing. It's mostly just kind of like, if we did this, this is what our scatter plot looks like. If we wanted to fit a linear model, this is kind of what it looks like, and it throws in some error bars and stuff. Let me see, Seaborn LM plot. Let me see what the other options are. Okay, there's a lot of options. Okay. You can, instead of regular linear model, you also have the option for like low S regression, stuff like that. Low S equals true. Okay. And then, if you fit the linear model, you can also ask for a residual plot, which, it's still kind of, this feels like we're doing some analysis, but this is mostly kind of just like, we threw this in here, and then do we see patterns in the residuals? It's mostly kind of for that rather than like a heavy-duty statistical analysis here, okay? An interesting thing you can do is you can kind of facet the thing, and you can say X is total bill, Y is tip, and here you can throw in hue equals a categorical variable. So here I'm throwing in smoker, yes or no, and it will fit basically two models to this thing. Now, let me see if I can copy the faceting stuff here. And let's just kind of compare. So we'll do column is smoker. And then what we will do is we will pass SNS LM plot, X equals total bill, Y equals tip. And do I need any of this other stuff? I don't think I need that, okay? Shoot, okay. Got an unexpected keyword argument color. I don't know where the color is coming in.
Oh, for column? Maybe that's what it is.
I think facet grid.
Is COL short for color, perhaps? Or is
Col
it
is for
column?
columns.
Okay.
I don't know why. I don't think this is gonna work. Yeah, let's see this. Trying this on the fly here, so it's always risky, and it's not working. Here, maybe I don't want to. Axis distance. Total bill versus tip. Okay. All right. So, all right. It's not working. I'll have to figure this out here. Whoops. Okay. Sorry. Yes.
Was there parameters for like leverage points, outlier?
Yeah, it's not going to give us stuff like that. You do have the option. Maybe regression plot will be. So there's a regression plot, which is very similar to LM plot. It's a little bit more flexible than LM plot, and you specify the X and Y, and the data is kind of your general thing, but you can also say I want what did they do here? You can specify the order for regression plot. You can say order equals 2 for like a quadratic type of thing, and you have other options like robust equals true, which means normally you'll have some kind of outlier that messes up your thing, and you can throw in robust regression for something like that. Okay, if you want to get rid of the confidence interval band, that's also possible using CI equals none and stuff. So there's more options. This is fitting a logistic regression model, and you can say X is this and Y is this, and logistic equals true if you've got some kind of categorical variable. There's lots of examples in the in just the documentation pages. So changing things like order, logistic, lowest robust and log x, I guess you can do logarithmic regression here. Okay, but that's pretty much it for Seaborn. I mean, I don't want to say that's it. There's a bunch of they have their, where's their gallery? Okay, so they have a bunch of different things. Oh, here's one that we didn't really discuss. This is a heat map. This is kind of you plot correlations. So if you got a bunch of categorical variables or something, or not categorical, a bunch of different numeric variables, you can kind of see the correlations between these things, or and plot heat maps. Or here, or in this case, this is apparently we're looking at flight information over a span of from 1949 to 1960, and we kind of created this big 2x2 contingency table. All right, and so we just have counts of all of these things, and we can see, there was a lot more flights on July and August of 1960 than there were, any other time of the year. Okay, even for that year, and the number of flights increased. So that's heat maps, and then you got other things, right? So box plots, violin plots, the joint plots. Oh, this is a nice one. This is, I know it looks pretty, but so yeah, so they set up a facet grid, but and then did a bunch of mapping of kernel density KDE plots to the facet grid. Okay, so this is seeing stuff like this and then coloring it with a nice color scheme. Okay, so you can take a look at all of these examples at Seaborn. I would say, as far, probably just throw in, you should learn dist plot, okay? Because this is designed mostly for very quick visual exploration, all right? If you want to fine tune all of your graphics, you can do that, but for quick visual exploration, dist plot is super useful. Joint plot is useful. And then probably either swarm plot or the box plot functions for things of that nature. Okay, and knowing that you can map two categorical variables to a box plot and make these plots very quickly is a useful thing. Okay, and then facet grids are nice, but it's also easy to subset the data yourself and make histograms that way. So, but okay, that's all I had prepared for today for Seaborn stuff. I don't know if you guys have more questions on this. This is just kind of for exploratory visual analysis, and then
why would you use Seaborn as opposed to, I'm assuming there's a module out there that will do the plotting with things like the coefficients and stuff like that.
Yeah, so there's a module called stats models, and it's mostly for modeling the data and then occasional plotting. Okay, and that one's a little, so they serve different purposes. So Seaborn is again for kind of this exploratory visual analysis. You get some things, you're just exploring the data, you just want to do some quick plots, and you go, oh, this might be an interesting thing to explore, right? You just kind of see, is there a linear relationship between here and here? Maybe this is something we can explore with stats models or something like that. Maybe I can build a more intricate model there. So the purpose of Seaborn, again, is to make some of these common statistical summary displays very easy, rather than the slightly more cumbersome matplotlib notation. Okay. All right. I think that's good. I think most of you guys have filled out the form for your teams. Some people are lagging, but I don't think those people are here. So we'll see what happens. I'll talk about this on Monday, but and then I don't know how much time you can devote to it this weekend. But just start thinking about what kind of data set you want to start exploring, and that will probably be your second checkpoint, is selecting at least one primary data set, and then of course as time goes on, if you want to have like secondary data sets to add there, that's fine. But probably your checkpoint next week will be identifying a primary data set for your project analysis. Okay, have a great weekend. I hope you guys hope to see you guys at Data Fest, and good luck with all of that there. And all right, so we'll see you guys in a little bit. Okay.